Yeah, good day, viewers. You are welcome to my YouTube class. Now, today, we want to look at some questions under SURD. So, I will start by telling us what SURD is. Now, SURD is a very good aspect, an important aspect in mathematics, which you're expected to know. So, when solving problems, of course, now you are going to, there's no way you're not going to meet application of SURD theorem. Now let us now start with the definition of SURDs. Now what do we call SURDs? Now SURDs are irrational numbers which are square root of rational number. I come again. SURDs are irrational number which are square root of rational number. So I think there's a need for us now to know what rational numbers are and what irrational numbers are. Now, I will start with rational number. Rational number. Natural numbers are numbers that can be expressed as fractions. It can be expressed as fraction of this form A over B, where B is not equal to 0. So any number that can be expressed in this form now, so we call it rational number. But irrational number, these are numbers that cannot be expressed as fraction. So it's just the opposite of rational number. So now let's start with example of rational number. Example of rational number is your 2, your 7 over 3, 9. 9 can be expressed as fraction. 9 is the same thing as 9 over 1. Now let us look at irrational numbers. So irrational numbers are numbers that cannot be expressed as fractions. E.g., we have square root of 3. You cannot express this as a fraction. Now we also have cube root of 6. We also have pi. Pi is also an irrational number. All of these are examples of irrational number, but we are concerned about irrational number whose square root or which has a root of rational numbers. That is, SURD is an irrational number. The first thing is irrational number, that is number that cannot be expressed as fraction, and they are square root of what? Rational number. So that's the definition of SURD. All right, now, so we now move down to the principles in SURD theorem. So let us look at the principle that guides SURD. Now, I will start with the first one. Square root of A times B is the same thing as square root of A times square root of B. Okay, now the second one, square root of A over B is going to give you square root of A over square root of B. Now another one, square root of A times B raised to the power of 2. The answer is going to be B square root of A. And let us look at one again. Square root of A plus B is not equals to square root of A plus square root of B. Let's take note of this. The same thing also applies to this. Square root of A minus square root of B is not equals to square root of A minus square root of B. Okay, so all these principles that I have here is something you need to know ordinarily. It's going to help you while solving problems under SURDS. Okay, so the first one, when you are multiplying SURDs together, so it can be expressed like this. This can be expressed like this. This can also be expressed like this, division in SURD. So when you have a perfect square in SURD like this, so this perfect square comes out and the 2 here will leave. So we have it as this. Okay, so and this will not hold. So you just need to take note of this. This also will not hold. All right, now let's begin with examples. Let's begin with examples. So I'm starting with the first example. The first one, example 1, we have express the following. Express the following in basic form. The first one is square root of 75. The second is square root of 54. The third one, square root of 200. Okay, square root of 200. All right, now these are single SURD. Just like I defined SURD earlier, I said SURDs are irrational number, which are root of rational number. You see what we have inside now, all of this now, they are rational number. So SURD are irrational number. That means that SURD cannot be expressed as fraction. Okay, so these are square root of rational number. 75 is rational number. So now they are single SURD. This is a single SURD, single SURD, single SURD. So you have to express this in basic form. Now, if I must express a SURD in basic form, now what I'm going to do now is that I must be able to express the rational number inside as a multiple of 2 factors, where one is a perfect square. I come again. Now, to express a SURD in basic form, we are going to express this number inside, that is the rational number. You express it as a multiple of 2 factors, where one of the factor will be a perfect square. So now what is a perfect square? A perfect squares are numbers that when you find the square root, you have whole number. All right, example of perfect square is your 4, your 16, 25, 100, and so on. They are perfect square because you can find, when you find their square roots, the answer is going to be what? Whole number. So now let's start with the first one. Now the first one is square root of 75. Square root of 75. Now I'm going to express this as products of 2 factors, where one of it must be a perfect square. Now look at this. This is 3 times 25. 25 is a perfect square. So now I'll write it this way: square root of 25 times 3 is the same thing as 75. Okay, don't forget the rule I gave. Now once you have this kind of expression, so you can express it in this form. So that means this becomes square root of 25 times square root of 3. Okay, so what will the answer be now? So square root of 25 is 5. So that's going to be 5 square root of 3. So this is going to be the basic form of this. Okay, so now let's look at the second one. Let's look at the second question. What do we have there? We have the square root of what? Square root of 54. That is what we have there. Square root of 54. All right. Now, how do we express this 54? Now you begin to think of perfect square that we go in. or you look for the highest perfect square that will go in it. So the perfect square that is going to go in 59. And when you look at it, 9 is a very good number that will go in this. All right, so you begin to look at it now. 9 times what will give you 54, and that's 9 times 6. So that means I'll be expressing this as 9 times 6. So I now have a perfect square. So that means square root of 54 now becomes 9 times 6. All right, 9 times 6 is 54. So this gives you square root of 9 times square root of 6. All right, so now square root of 9 is what? 3. So we have 3 times square root of 6. So this is going to be the answer. So this is the basic form of this. Now let's look at the third one. That one is a very simple one. Okay, so how do you express this? Now I begin to think of perfect square that will go in this. Okay, so I'll begin to think of 4. 4 will go in this one, but I will not pick 4. I will look for the biggest perfect square that will go in it. And I think that's going to be 100. So 100 times 2, that is 200. So this becomes 100 times 2. So and that is going to be 10 square root of 2. So this is the basic form of this. All right. So I want to believe gotten what I just explained to you. All right. So now let's move to another question. Okay, now let's move to the second example, example 2. Write each of the following, as complete square roots, as complete square roots. The first one is 10 square root of 7. The second one, 2 square root of 11. And then the third one, 4 square root of 3. Okay. All right, so this is the second example. Now, before we solve this, I want you to drop a message. I want to know where you're watching from. So drop a message and let me have your impression about the class. All right. And also, if you have not subscribed to this channel, please try and press the subscription button and also drop a comment. And you can also like the video. Okay, now let's look at this. Now write each of the following as complete square roots. Write each of the following as complete square roots. Okay, now when you look at all what we have here now, they are what? They are stored in basic form. Stored in basic form. So we want to return them to a complete square root. So let's look at the first one. The first one is 10 square root of 7. Now, you bring this one inside. When a number comes inside the square root, it becomes a perfect square. It turns to a perfect square. So this one will now be square root of 7 times 10 square. So it's 10 here. Once it comes in, it becomes a perfect square. So it's going to have a power of 2. So, and this gives us square root of 7 times 100. So the answer now is going to be square root of what? 700. So that's going to be the answer. Now let's look at the second one. 2 square root of 11. You know what to do now? This number comes in. It turns to what? 2 square. So we have square root of 11 times. Okay, now let's look at the third one. The third one is what? This comes in, becomes square root of 3 times 4 square. And that's going to be square root of what? 3 times 16. The answer is going to be square root of 48. So that's going to be the answer to this problem. Now let us look at another example. Let's look at another example. Okay, now let's look at the next example, example 3. Now find the square of each of the following. Now we have to square each of the following. We square it. So now let's look at the first one. All right, now let's move to another question. Example 4. Example 4. Simplify the following. Simplify the following. We have A, 2 square root of 12 minus 3 square root of 48 minus square root of 75. B, we have 4 square root of 200 minus 40 square root of 2 plus square root of 8. And the last one, we have 5 square root of 2 minus 3 square root of 18 plus 4 square root of 72. Okay, and the last one plus 2 square root of 75. Okay, so that is the question. So we are solving this problem together. Simplify the following. Simplify the following. Now, before we simplify, if you have not subscribed to this channel, please try and subscribe. Share this video with your friends. Let them know what is going on here. And also drop a comment. I want your impression about the class. All right, now, so let's look at the first question here. Now, we have 2 square root of 12 minus 3 square root of 48 minus square root of 75. Now, all right, now let's look at the question. The first one is 2 square root of 12 minus 3 square root of 48 minus square root of 75. Now, I said earlier that you are going to look for a perfect square, the biggest perfect square that will go in this. So you look for its multiple here, the same thing here and here. So now let's start with the first one. So we have 2. Now this is going to be square root of, now what is the highest perfect square that will go here? That's 4. That's 4 times 3. So this will be 4 times 3. Okay, minus 3 open brackets. What is the highest perfect square that will go here? That is going to be 16. 16 times 3, right? So the last one here, we have square root of the perfect square that will go here, 25. 25 times 3. Okay, so now you find the square root of 4, find the square root of 16, and find the square root of 5. So when you bring it out. So now the square root of 4 here is 2. So this will now become 2 times 2 square root of 3. Okay, so now these have been brought out. Now the square root of 16 here is 4. So we have minus 3 times 4 square root of 3. Okay, square root of 16 is 4. So this last one, that's minus 5 square root of 3, because square root of 25 is 5. So, and this gives us 4 square root of 3 minus 12 square root of 3 minus 5 square root of 3. Now look at it. We have minus 12 square root of 3 minus 5 square root of 3. So how many will that one be? How many square root of 3 minus square root of 3 are we going to have here? This and this. So that's going to be minus 17 square root of 3. So this becomes 4 square root of 3 minus 17 square root of 3. Okay, so now we have 4 minus 17. So we'll be having minus what? Minus 13 square root of 3. So this is going to be the answer to this first question. Now let's look at the second one. All right, we have 4 square root of 200 minus 40 square root of 2 plus square root of 8. Okay, now to do this, this is 100 times 2. So when you find square root of 100, that's going to give you what? 10. So that 10 will multiply itself with 4. So this will be 40 square root of 2. Hope you get that now. So this is already in its basic form. So 40 square root of 2 plus, now this is 4 times 2. 8 is 4 times 2. So when you find square root of 4, that's going to be 2. So it will be 2 square root of 2. Okay. So now look at this. This and this will cancel out. This is plus 40 square root of 2. This is minus 40 square root of 2. They are the same but opposite sign. So they will cancel out. So the answer will now be what? 2 square root of 2. All right. So that's going to be the answer to that. Now let's look at the last one. See, we have 5 square root of 12 minus 3 square root of 18 plus 4 square root of 72 plus 2 square root of 75. Now, to do this, we express the surds there in their basic form, just like we did our previous ones. So this will be 5 square root of 4 times 3. It's the same thing as 12. So minus 3 square root of, this is 9 times 2. So 9 times 2. Okay. So plus this 4 square root of 36 times 2. 36 times 2 plus 2 square root of 25 times 3. 25 times 3. Okay, so here we now have, now the square root of 4 here is 2. So that 2 will multiply this 5. That gives us 10. So we have 10 square root of 3. Okay, minus, now when you find square root of 9, you have 3. So that 3 will multiply the 3 outside here. So we have minus 9 square root of 2. Minus 9 square root of 2. Okay, now let's look at the next one. This one is 6. All right. Square root of 36 is 6. So 6 times 4. That's what? That's 24. So that's going to be plus 24 square root of 2. And the last one, you find square root of 25. That's 5. So 5 times 2, that's 10. That's going to be plus 10 square root of 3. All right. So now let's look at it now. So you can see we have 10 square root of 3 here. Another 10 square root of 3. How many square root of 3 do we have now? So we have 20 square root of 3. Now look at this. We have minus 9 square root of 2. We have plus 24 square root of 2. So how many square root of 2 are we left with if we take away 9 square root of 2 from this 24 square root of 2? So what are we going to have? So that is going to be what? Plus, is that 15? So that's going to be 15 plus 15 square root of 2. All right. So now you can tidy up this. See, we have a common factor. 5 can go here, 5 can also go here. So you have 5 open bracket 2, 5 times, that's 4 square root of 3. So when you divide this by 5, you have 4. So plus 3 square root of 2. So this is going to be the final answer to this problem. So, right, so that is the solution. So I need to drop a message. I want to know where you are watching from. So drop a message. Let me have an impression about the class. And also, if you have not subscribed to this channel, please try and do that. All right, and also share this video with your friends. Let them know what is going on here. Now we will be moving to another question now. So that is going to be example 5. That's example 5. Example 5. Example 5. Simplify the following. Simplify the following. A 2 square root of 2 plus 3 square root of 5 raised to the power of 2. B 1 minus square root of 3 times 1 plus square root of 3. The third one, 2 square root of 6 minus 1 square root of 3 minus square root of 2. Okay, so now can we solve this problem together? Now let's solve this problem together. Now you have to simplify the following. Now the first one, we have a 2 square root of 2 plus 3 square root of 5 raised to the power of 2. So now we are going to expand this. So we have 2 square root of 2 plus 3 square root of 5 times 2 square root of 2 plus 3 square root of 5. Okay, so this is equal to this. So you expand. So I pick this, I put it beside everything in the bracket here, and the second one I do the same thing. So now this expression turns to 2 square root of 2 times 2 square root of 2 plus 3 square root of 5. Pick the second one, plus 3 square root of 5 times 2 square root of 2 plus 3 square root of 5. Okay, so you open the bracket. You use this to multiply the two terms inside the bracket. Now, use this number outside to multiply the number here. That is 2 times 2, you have 4. Square root of 2 times square root of 2, that's 2. So that's going to be times 2. So that's going to be the first one. Use this to multiply this again. Plus 2 times 3, 6. Square root of 2 times square root of 5. That's going to give you square root of 10. Now, you move here now. This times this. So 3 times 2. That's plus 6. Square root of 5 times square root of 2. That's square root of 10. Now, this times this. 3 times 3. That's 9. Square root of 5 times square root of 5. That's going to give you 5. Okay, so this turns to 8. 4 times 2 is 8. Now look at this. This and this, when you add together, that's going to give you 12 square root of 10. You have 6 square root of 10, 6 of them, another 6 of square root of 10. So making how many square root of 10? That's 12. That's plus 12 square root of 10. And look at this, 9 times 5, that's 45. So you can add this and this together of the same term. So that's going to give you 53 plus 12 square root of 10. Now, this is going to be the answer to the first part of the question. All right, now let's look at the second one. The second one, we have 1 minus square root of 3 times 1 plus square root of 3. Now you see, to solve this reminds me of identity in mathematics. That's difference of two squares. Whenever we have, I want you to look here, when you have a raised to the power of 2 minus b raised to the power of 2. These are two squares. So it's difference of two squares. Difference in mathematics means subtraction. So the answer is going to be a minus b times a plus b. You get that now? So this is the same thing as this. So now I can reverse this back to this. So when you look at this now, they have the same term, just like we have a and b, 1 and square root of 3, 1 and square root of 3, opposite sign, opposite sign. So I'm reversing it back to something like this. So now this will now turn to, instead of being expanding, going through this rest, so I will have it as 1 square, this is like my a, minus this b, so square root of 3 whole square. So that's going to be 1 minus. So square root of 3 times square root of 3, that's going to give you 3. We said that earlier. So we have 3. So 1 minus 3. So that's going to give you minus 2. So that is the answer to the second part of the question. Now let's look at the third part. Let's look at the third part. The third part of the question. Okay, so what do we have there? We have 2 square root of 6 minus 1 times square root of 3 minus square root of 2. So this term we multiply this one we also multiply this. So we have 2 square root of 6 times everything we have here. That's going to be square root of 3 minus square root of 2. We pick the second one, so that's minus 1. Always remember to pick the sign with it. Minus 1 times square root of 3 minus square root of 2. Okay, so now let's multiply. Now 2 times 1, because this one is 1. 1 square root of 3 is the same thing as square root of 3. So 2 times 1, that's 2. And square root of 6 times square root of 3, that's going to give you square root of 18. Square root of 18. Now use this to multiply this. We have minus 2 square root of 12. Okay. 6 times 2 is 12. 2 times 1 is 2. So now minus 1 times square root of 3. That's minus square root of 3. Minus 1 times minus square root of 2. That's going to be plus square root of 2. Okay. So from here, you see, you have to express this one in its basic form, because you can see a perfect square here. That's 9. 9 can go in 18. So, and that's going to be 2. So 9 goes here is going to be 2. So square root of 9 is 3. So that 3 will multiply 2. So 3 times 2, that will be 6. So we have 6 square root of 2. Okay, hope you get that. 18 is 9 times 2. So the 9 will come out. When it comes out, it becomes 3, because we are finding square root of that 9. So that 3 times 2, we have 6. So we are left with 2 inside the root. So now the same thing also applies to this. Now 4 times 3 is 12. Square root of 4 is 2. So that 2 will multiply itself with this. So we have 4 square root of 3. Okay. So now let's look at the next one. We have minus square root of 3 plus square root of 2. Okay, so let's see how to tidy up this. Now this is 6 square root of 2. This is 1 square root of 2, making 7 square root of 2. Now look at this and this. This is minus 4 square root of 3. This is minus 1 square root of 3. So that gives you minus 5 square root of 3. So this is going to be the answer to the third question. All right. So we are going to move on. So if you are watching, I want you to drop a comment, your impression about the class. Let me know where you are watching from. All right, now let's move to the next example. That should be example 6. Example 6. Example 6. All right, so now we have given that square root of 2 equals to 1.414, and the square root of 5 is equals to 2.236. Okay. Evaluate each of the following. Evaluate each of the following. Giving your answers. Giving your answers correct to 3SF, 3 significant figure. So we have A 10 square root of divided by square root of 2, and B 15 over square root of 5. Now let's look at the question here. Now we have been given the value of square root of 2 and square root of 5. So and we have to evaluate this. Now to do this, I will not just go ahead and just substitute here. I will just be propounding the problem. So the first thing to do now is to rationalize. What do we mean by rationalizing? You turn the irrational number to rational number, because this is a surd now. So you turn it, the denominator here, we are going to turn it to rational number. The denominator is not going to be an irrational again, it's going to be a rational number. That's the meaning of rationalizing. So we are going to rationalize the denominator. So now let's look at it. We have 10 over square root of 2. So if I want to rationalize, I'm going to multiply the numerator and the denominator with the denominator that I have here. The denominator here is square root of 2. So I will multiply this by square root of 2 over square root of 2. So that's what I'm going to do. You know, this is not changing anything, because square root of 2 divided by square root of 2 is still 1. So it's still the same thing as 10 over square root of 2. So what I'm doing now is I'm rationalizing the denominator. So, and this gives you have 10 times square root of 2. That's going to give you 10 square root of 2 over square root of 2 times square root of 2. That's going to give you 2. So you can see now we have rationalized it. So the number we have here now is a rational number. It was irrational before. Now it's now rational. So let's simplify. So 2 goes here 1, 2 goes here 5. So we have 5 square root of 2. So that's what we have now. So, and now this turns to 5 times now the value of the square root given. So we have 1.414. So when you multiply this, let's multiply together. Now 5 times 4, that's 20. You write 0, keep 2. 5 times 1, 5, plus these 2, we have 7. 5 times 4, 20. You write 0, you keep 2. Okay, 5 times 1, 5, plus 1, that's 7. Okay, so that is our answer. So now the question asks you to express your answer in 3SF, 3 significant figure. So you count 3 digits from the front, 1, 2, 3. So this is what you are writing. So you're writing this out. So therefore, your answer now will be 7.073 SF, 3 significant figure. So that's going to be the answer to that. Now let's look at the second one. So we have 15 over square root of 5. Now what do we do here? We rationalize the denominator. So we multiply the numerator and the denominator with square root of 5. So this now turns to 15 over square root of 5 times square root of 5 over square root of 5. So you use this to multiply this. this to multiply this. So we have 15 square root of 5 over square root of 5 times square root of 5. That is going to give you 5. Okay, so now 5 goes here 1, 5 goes here what? 3. So we have 3 square root of 5. So the answer will now be 3 times, what is square root of 5? Square root of 5 has been given in the question. That's 2.236. So we multiply. Now let's do the multiplication together. 3 times 6, that's 18. Okay, so we write 8. We keep 1. 3 times 3, 9, plus 1, 10. You write 0, you keep 1. 3 times 2, 6, plus 1, 7. So 3 times 2, that is 6. You have to express your answer in 3SF. So you count 1, 2, 3. So this is what you are writing, 6.70. But look at it, the next one is up to 5. So you turn it to 1, you add it to this. So your answer now is going to be 6.71. So that is going to be the answer to that problem. All right. So I want to believe you understand these concepts. All right. Now let's move to the next example. That is example 7. Example 7. Example 7. Example 7. Rationalize the denominator. Rationalize the denominator of each of the following and simplify. So we have A, 4 square root of 3 minus 2 square root of 2 all over 1 plus square root of 2. And the second one is 8 plus square root of 7 over 8 minus square root of 7. Okay, now let's look at the problem here. So we have to simplify this by rationalizing the denominator. So the first thing to do now is you find the conjugates of the denominator. You find the conjugates of the denominator. So you multiply the numerator and the denominator with the conjugates of the denominator. So now what do we call conjugates? Now look at this. If I have a plus square root of b, the conjugate of this surd now is a minus square root of b. Just change the sign. So conjugate of this is this. Conjugate of this is this. All right. So if I have square root of 3 plus 1, the conjugate of this is going to be square root of 3 minus 1. That's all. So now, in this case now, what's going to be the conjugate of the denominator here? I know you know it. That's going to be 1 minus square root of 2. So we'll multiply the numerator and the denominator with 1 minus square root of 2. So this will be, so I'm multiplying this by what? 1 minus square root of 2. The denominator 1 minus square root of 2. Okay, so I'm multiplying the numerator and the denominator by the conjugate of the denominator given in the question. All you just need to do, just change the sign here. Use it to multiply the numerator and denominator, right? So now let us see. So what do we have? Okay, so now we expand the numerator. Let's expand. So we have 4 square root of 3 times, put it beside this first one beside this, the second one too. So 1 minus square root of 2. You pick the second one with the sign minus 2 square root of 2 times what we have here. So that's 1 minus square root of 2. Okay, do you get that? So now you now divide by. Now see the denominator. I don't need to express it like this. Look at the denominator. The denominator is difference of 2 squares. They are the same thing, but the only difference is one is having plus here, while the other is having negative. So don't forget what I said earlier. You are applying difference of 2 squares. Just look at this negative one. Just square the numbers we have there. So you square 1 and you also square root of 2. So that's what we're going to have here. So that's going to be 1 square minus square root of 2 square. So that's it. Okay, you can see to solve this is very easy. So now we open the bracket. Square root of 4 square root of 3 times 1, we have 4 square root of 3 minus 4 square root of 3 times minus square root of 2. That's going to give you 4 square root of 6. Okay, so because 3 times 2 is 6, 4 times 1 is 4. So the same thing here, going to give you minus 2 square root of 2. 2 square root of 2 times 1, that's what it is. Now, here, minus times minus plus. So 2 square root of 2 times square root of 2. That's going to give you 2 times 2. This 2 is this. Square root of 2 times square root of 2 will give you 2. Because square root of 2 times square root of 2 is square root of 4. Square root of 4 is 2. All right, so I don't need to be writing square root of 4 since I know it's going to be 2. So now, let's move on. Everything all over. When you square 1, 1 times 1 is 1. Minus square root of 2 times square root of 2 is going to give you 2. Square root of 2 times square root of 2, that's square root of 4, and that's 2. So we have 2 here. So now let's look at those that are similar. So we have 4 square root of 3. Okay, that's the only one we have. Minus 4 square root of 6. Okay, so nothing is similar. So we have minus 2 square root of 2 plus 4. Okay, so everything all over minus 1. Okay, because 1 minus 2 is minus 1. So doing this, instead of me writing fraction, I'll just multiply everything here by minus 1. All right, so that means my final answer is going to be minus 4 square root of 3 plus 4 square root of 3, 6, plus 2 square root of 2 minus 4. Okay, see, the sign changes to negative. This changes to positive, to negative. So this is going to be the answer. You will see that there's no how you can join this and this together. The SURDS are not similar. This is not similar to this. This is not also similar to this. All right, so that is going to be the answer to the first part of the question. Now let us look at the second one. Please, I want to know if you are just joining the class. I want to know where you are watching from. Let me have that, and let me have your comments. And also, if you have not subscribed to this channel, kindly subscribe, share this video with your friends. All right, now let's look at the second one. So the second one, B, we have 8 plus square root of 7 over 8 minus square root of 7. So that is what we have here. So how do we solve this? don't forget what I said earlier. You look at the denominator. You use the conjugate of the denominator to multiply the numerator and denominator. That's all. Very easy. So what we have here, you put it here, you put it down. Just ensure that the sign changes. Okay, can we do that now? So this gives us 8 plus square root of 7 times the conjugate of this. That's 8 plus square root of 7. Hope you get that. All over what we have here is 8 minus square root of 7 times 8 plus square root of 7. You can see this is the question given. We have multiplied the numerator and the denominator with the conjugate of the denominator. Okay, so now let us expand the numerator now to 8 times 8 plus square root of 7. We pick the next one, plus square root of 7 times 8 plus square root of 7, right? All over. Don't forget, we are going to be making use of principle of difference of two squares. So you square this and you square this, the negative one. You square this, just disregard this. So square this and square this. We have 8 squared minus square root of 7 squared. All right, so now this now turns to 8 times 8, that's what? 64. 8 times square root of 7, that's plus 8 square root of 7. Now this times this plus 8 square root of 7. All right, so square root of 7 times square root of 7, that's what? 7. So that's square root of 49. Square root of 49 is 7. So everything all over, this is going to give you what? 64 minus 7. Square root of 7 times square root of 7 is 7. So now you add this and this together. So when you add, that's going to give you 71. 64 plus 7, that's 71. Now let's look at this. 8 square root of 7, another 8 square root of 7. That becomes what? Plus 16 square root of 7. Everything all over. So when you take this away from here, what do you have? You have 50 what? That is 57. Okay, so you have 57. So that's what you're going to have. That will be 57. All right. So now that is going to be the answer to the second part of the question. All right, we are moving on. All right, now let's move to the next example. So we have like one or two examples to go. Okay, so this is another question. This is another question. Now let's look at this question together. Now you have to find the square roots of this. Find the square root of 7 plus 2 square root of 10. So we start by saying, let's square root of A plus square root of B represents the square roots of 7 plus 2 square root of 10. You get that now? You know, we want to find the square root of this. We make an assumption. Let this be the square root of this. So now